Okay, how do we go about to solve this question? Okay, this is a question which does not need any calculation. It's more of a conceptual question. Okay, it shows a car moving forward. So it's moving forward. It's actually moving in the direction of Q. Okay, moving forward. So a car will move to the front. Okay, four of the forces acting on it is P, Q, R, and S. So if you notice, if I label Q is pushing the car forward. So this is actually called my Q is actually known as my applied force. So when you look at this type of question, it's good to start to identify which type of forces it is talking about. So in this case, P is actually in opposite direction with the applied force. So P is actually known as my opposing force. Okay, because it's in opposite direction. Okay, now let's look at S. S is also opposing the motion. Okay, so S is also known as the opposing force. Okay, because it's in opposite direction with the direction that the car wants to move. Okay, what about R? R is actually, if you notice, R is also a force, but it's actually a force due to gravity acting on the object. Okay, so the object will always be acting downwards. So in this case, there's a special word called weight. So R is actually known as the weight of the car. Okay, so once we've identified the different forces acting on the object, it's good to start to analyze the question. Okay, it says which force or forces will increase. Keyword is increase in value will cause a increase in speed. We talk about increase in speed. If you notice this word called increase in speed in physics is actually known as my acceleration. So this is a very important concept. Once you see the keyword, you have to link to the correct concept it's asking. So the question is, how do I increase the acceleration? You notice, if we recall Newton's law of motion, there's one law which is called F is equal to relating to acceleration A. F is actually equal to M times A. So you want to increase A, the other option, because the mass of the object remains the same, the next option is to increase the resultant force. So in this diagram, how do we increase the resultant force? Okay, resultant force in this case, F is actually equal to my applied force. Okay, resultant force is actually equal to, because the applied force is in the same direction as my resultant force F. Okay, so you notice I have to subtract all the forces that's acting in opposite direction. Okay, so it's actually subtracting all the opposing forces. Okay, so this is the concept we are talking about. So in this case, F is actually equal, you look at the symbol, it's actually equal to Q minus P is also minus S. So it's Q to the right, subtracting P as well as S. Okay, then I'll get my resultant force to the right. So how do we increase the resultant force? We have to, if you notice, we have to increase the Q. So the answer will be Q, because it's asking for, you look at the question, it's asking for an increase in value. So we can only increase Q to increase the resultant force. Okay, so that's why the only answer left to answer is actually to increase Q. We can't increase P and S, because if we increase P and S, the opposing force will be bigger, and I can't increase my resultant force F. So this is the best answer that we have, which is B. So that's all for this question.